Welcome to the project demonstration of solar integrated roof. So in this project we have interfaced the roof solar panels which we have made manually, which was connected in series, and another extra solar panel, and we are going to compare the voltages coming out from this solar panels, and that will be displayed on the LCD continuously, and that voltage read by our PIC microcontroller. So here using the PIC microcontroller PIC16F73, which will read the continuous voltage through these voltage sensors. So here using the 10:1 voltage sensors. Why? Because we are getting 12 volts maximum from these solar panels, and this is the 5 volt solar panel. So in order to measure the 12 volts, our microcontroller can't handle above 5 volts. So for that purpose we need to use the potential divider, which will divide the voltage in 10:1. Means if the controller getting 1 volt after this voltage sensor, then it will calculate as a 10 volts, because 10:1 potential divider ratio we are using here is 10 kilo ohm and 1 kilo ohm. Across 1 kilo ohm we are measuring the voltage. So when we are getting the 1 volt across the 1 kilo ohm, then it is total is 10 volts input. So in that manner we are going to dividing the voltage, which can measured by microcontroller easily, and the input from this solar voltage sensors is given as input to the A0 A1 pins, and based on that it will do the boost operation with help of this boost circuit. So whenever the voltage is not sufficient to charge our 12 volt 2 amps battery, then our microcontroller will boost up the voltage. Means whenever it is 8 volts minimum, then only we can boost up to 12 volts, and that 12 volts is sufficient to charge our battery. So that output is given as input to the 12 volts 2 amps battery. So if you observe, this battery pack consists of 2 battery packs. One battery pack is of 3 4 volt 1 amp batteries are in series, so we will get 12 volt 1 amp, and this is a 12 volt 1 amp. So directly these two are in parallel again, so we will get 12 volts 2 amps DC output, and this is a DC load. And one more charger we have provided for you is transformer. So if the sunlight is not available, which is not sufficient to charge our battery, then we are going to making use of this transformer by providing the 230 volts AC input to this. So when we on this transformer, then the green light will get switched on, so which will show the status of the battery is charging. So once the battery is discharged, so it will take 8 hours to be fully charged. So after that we can utilize that to the project. So once the 8 hours completes, you can switch off the charger, and if you forgot to off, also no need to worry about that. This charging circuits will block the current flow from the charging circuits to the battery. Means whenever it's become the high potential one, then automatically these diodes block the current flow from the battery to the charging circuits. So let me explain you the flow from the solar roof also. So these three are in series, so we will get 12 volts, maximum of 15 volts we will get that. So we need to connect the S1 at this S1 slot. So it will accept in only one direction. You can check that, right? And parallelly that roof solar voltage is parallelly given to the voltage sensor, and again from this directly parallel to this charging circuit. Same here also, input from the small solar panel. So you can see this, and that is the output is parallelly to the voltage sensor and this voltage charging circuits. So here we can observe that. So here we are using AC inputs. That's why we are using these 4 diodes as a rectifier, so which will convert the AC to DC. But on this one there are also same 4 diodes. So the purpose here 4 diodes is not a bridge rectifier. They'll act as a polarity corrector. Means if you connect this in reverse bias, here in reverse bias, then the charging circuit may get damaged, because the place is given to the minus of the battery and minus plus to the battery. So then in order to rectify that plus to plus, minus to minus, we are making use of these 4 diodes as a polarity corrector. Means as we know that rectifier will convert the AC to DC, nothing but alternating current to the direct current. So if you are providing the DC input also, but if you provide the negative to positive, positive to negative, reverse direction, reverse polarity, then these diodes will rectify that to plus and minus to minus, and that is input to the same 2 diodes to protect the charging circuits whenever there is no sunlight available, and then through this capacitor. So that is parallelly from this solar panel 1 charging circuit, solar panel 2 charging circuits, that is input to this boost converter, and based on the input voltage from the solar panel, our microcontroller will measure that and do the respective actions like boost operation, and that is input to the again battery directly. We can see that. So to the battery here, So this is the from the boost converter, and this is from the charging circuit from the transformer, and this is the wire connections to the load. So if you want to utilize that load from the battery, directly you can on off the switch, and this is the main on off switch to making use of the total system to run. So once you switch on that, welcome message will be displayed on the LCD screen, and after that solar panel 1 voltage displayed on the LCD and solar panel 2 voltage displayed on the LCD. So as we can see that S1 is we connected that in series, so that's why we are getting the more voltage, and S2 is a low voltage, so it is a single solar which is directly available in the market. So when we place this under the sunlight, so that we will get the high voltage which is of maximum voltage can be generated from this solar panel circuit.